Hey learners, welcome to Math. So learners, in this video, we will see a problem based on leaders of an array. Okay, so given an array, we have to find the number of leaders. So what is a leader? A leader is an element that is greater than all the elements on the left side. Okay, so if AI is greater than all the elements from a0 to ai minus 1, then we will say that ai is the leader. Okay, so now just see an example. So there is an example over here that you can see that the first element 1 will be a leader, will always be a leader because there is no element on the left of it, and it is all the, then it can be said that it is greater than all the elements towards its left, so it will be a leader. Okay, now the second element 2, so it is also the leader because it is greater than all the elements towards its left. Okay, now just see for the third element, which is 5. So it is also a leader because it is greater than all the elements towards its left. You can see it is greater than 2, it is greater than 1. Now just see for the third index element, which is 4. Now but this cannot be a leader because it is not greater than all the elements towards its left. It is less than 5. Now just see for 10, the fourth index element. So it is a leader because it is greater than all the elements towards its left. Okay, so now it's the C for 21. It is also a leader because it is greater than all the elements towards its left. Now just C for 9. It is not a leader because it is not greater than 21. Okay, and it is not greater than all the elements towards its left. So what can be the brute force approach for it? The brute force approach can be that you can just make a loop that will run for each element. Okay, and you have to make another loop which will run inside that loop, and it will run for all the previous elements of the current element. So if there is an element ai for this, so the inner loop will run from here to here. If there is an element ai for this, the inner loop will run from here to here. So you can see the inner loop is running for approximately till here. If we reach till, in the worst case, it will run for n times. So the time complexity for it will be what? Order of n square, and the space complexity will be order of 1. But so we have to reduce the time complexity as it is a big time complexity. So there can be a optimized approach for it. So if you know the optimized approach for it, just comment out in the comment box, and now just proceed. Okay, here is the optimized audio for it. So we can use carry forward in this solution, such as we will just start from the left. Okay, and we will just move towards the right, and while moving towards the right, we will just keep track of the max element so far. Okay, with this you can just get the solution. Just see the pseudocode for it. So there is a method count leaders which is taking an input of integer array. Okay, so first to make the max so far element as the 0th element of a, and we will make the count as 1 because the 0th element of a will always be the leader. Okay, so now we will just start the loop from I is equals to 1, and we will go till I n minus 1. Okay, now we will check that if ai is greater than max so far, we will just increase the count by 1, and we will also update the max so far with the ai. And when this loop ends, at last we will just return count. So with this we can get the solution. Yeah, okay. So what can be the time complexity for it? So you can see that this loop is running for n times. Okay, so the time complexity for it will be order of n only. So here I am writing the time complexity for it will be what? Order of n, and the space complexity will remain as order of 1 only. Okay, so with this we will get the solution. So learners, if you like this video, just click the like button, do subscribe to our channel. We will be coming with more data structure videos, and also do give a feedback in the comment box whatever you liked in this video. If you need to improve anything, just give us a feedback for that. It will improve, it will help us in improving our teaching lecture. And just hit the bell icon. Thank you.